introduction. It's a pleasure to be here. Even though this talk is in a way a history lesson, it's also a very personal lesson, I think. I'm showing you the history of human-computer interaction from my point of view, as far as I know this. And this means I'm born and started my life in the Netherlands. And so I'm very much aware of what happened in the Netherlands since a very long period. And later on, I broadened my world, so there's a lot about Europe. And there's not too much about things behind Europe that I couldn't see myself. So I'm not pretending this is the history, this is a personal history. Well, I made it a serious talk, so I will talk a little bit about the life before the computer, and then I will go through the list of stuff here, more or less in decades. So the first start is well, really before the computer was there. Before computers were available, this was how people kept their stuff. People hand wrote their information, people kept their books in their bookshelves, if people needed to calculate, they used tools. So this is an abacus in a museum in Italy. It's a real computing tool. It's a physical computing tool. You can go there, you can do stuff, and you can calculate complex things. So this was used in banking, for instance. And in a way, using physical things to calculate means that you can really see what happens. You don't have to trust things behind the screen that you can't see. So, and then usability came up. This is a picture of a military testing situation where they were testing the usability of certain procedures. Usability as a word, we think that it was invented about 1936. There's a newspaper in the Palm Springs area where in 1936 a washing machine was, I think a freezer was advertised, and why should you buy the freezer? Well, one of the reasons was that there was proven usability. Interesting. But maybe a little bit about my personal background. My real education was just extended primary school. No computer science, no high school, whatever. But after and actually during my primary school time, I spent most of my time playing music. I played music. My real teachers are my music teacher and the teacher who taught me to paint, and the teacher who taught me to do jewelry and fine metal works. So this is my background, no computer science. And I remember at a certain moment when I was about 10 years old, we got a phone in the house, a telephone, and the telephone looks like this. Most of you have never seen a telephone like that, right? You had to turn the wheel to choose your numbers, interestingly. Well, you actually have seen them, because this is my Skype, and if I want to call my wife, Ellie, the symbol for that is the telephone that none of us will ever have in our house again, right? But we still use the symbol, and maybe we forget the actual meaning. We now just think this is a Skype number, right? It used to be a real physical telephone. When I was about 19 years old, I found a book. And in that book, I found a diagram like this, which shows the relation between different people. They happen to be Dutch people, and the arrows tells me, for instance, that Bart is talking to Tara, and Tara is also talking to Bart. The two of them have a two-way interaction. There's a pattern there. And Willem is talking to Karin, but Karin never talks back to him. So we call this a sociogram, and I was excited. I thought, wow, if we could model people's interactions like this, we could reason about people's interactions, we could support people's interactions, we could identify people that should sit next to each other in class, in school, and people that you would not like to sit next to each other because they talk too much. So this is a very powerful thing. So I thought, what can I do to learn more about this type of approach, an approach where you model relations between people. And somebody told me you should look at cognitive psychology. So in 1960, I entered the Free University of Amsterdam in the cognitive psychology department. And there were more things that inspired me. For one thing, in 1961, there was Doug Engelbart. Doug Engelbart invented the mouse. This is the original mouse he invented. It's a wooden box, and it has two wheels here and there. And by moving the mouse, the machine could detect where you were moving, the patterns of your movement, right? And so at that time, nobody could connect the mouse to a real computer and really work with it, but the idea was already invented. I didn't know that by that time, by the way, but that was the moment that I got interested in programming. And in 1961, as a second-year student, I got a job, 30 hours a week, so pretty much a full-time job, because I happened to be the only one who could read this book. This is the revised report on the algorithmic language Algol 60. Some of you know Pascal. Well, Pascal is the great-grandfather of Algol 60 is the great-grandfather of Pascal. And Algol 60 is a language in which you could program computers and tell them precisely what they should do for you. So this is just a chapter of the revised report. You see the type of printing. And in 61, I got hold of that booklet, about 60 pages. I read it, and I, in a way, understood. And I started to write my own programs, and the university offered me a job. So no longer just studying psychology, I was teaching programming for a computer. And I was, as a second-year student, in my class were full professors who needed to learn how to handle this new machine. And by the way, the computer was, my job was teaching programming, and my job was to develop models of human information processing that could run on such a machine. Psychologists thought if we could specify how people think, how people learn, how people perceive, how people make decisions, how people make choices, if we would really be able to specify it, we could write it down in such a program, and the machine could show us whether the model works, whether the theory holds. And the cognitive psychology groups, wherever in the world at that time, were using experiments with many data, and they needed to work with the data to use statistical modeling, and computers were a promise. Maybe we could use them. So this was my task. And this was the machine. This was my first machine for 9 hours a week. And this was very expensive. It's only machine in Amsterdam for 2 universities and the CWI, the Mathematical Center. And I was allowed to use that machine 9 hours. 9 hours, in my case, meant a night. Because during the daytime, other people who were more important and had higher ranks could use the machine. One night a week for 9 hours, the thing was mine. And you can see here the console is this desk where the lady is sitting, and you see a row of switches. And above the row of switches is a row of lamps. And if I was running a program and something went wrong, I could find out by using the console at which memory location something went wrong. And I could go to that memory location and I could change the value of the content, and then I could press a button and I could say, put this in another location. I could put a switch to another location and restart my program. This was real programming with a real computer. And next to the computer was the PhD thesis of Edgar Dijkstra. Edgar Dijkstra is, I think, world famous still, no longer, maybe. Well, he used to be world famous because he really improved the ideas and the concepts of computing. And his PhD thesis actually was the manual of my computer. So if something went completely wrong, you took the book, it was always on the desk, and you could work. And this is just a guy who is working. At the computer was this machine, and this is a telex machine. The telex machine could read paper tape, punched paper tape with 7 holes, and each hole, in fact, represented one ASCII code. ASCII code we still know, right? So ASCII codes could be transferred in printing, so this guy here with the long beard is working, and whatever he does will be printed on a line, and if the machine gives some output, it will also be punched in a paper tape and printed on the paper. So apart from the console, this was the way. So my algo programs were paper tapes. The data for my algo programs were other paper tapes. The output were paper tapes. And in a way, the paper was representing what was on the tapes. Another inspiration, I told you, I've been playing music all my life, and I'm aware that in history, musicians sometimes use tricks to compose music. This is a piece of music. It says that it's composed by Mozart, but actually it says musikalisches Würfelspiel, which is German, which means that Mozart played a game whereby using a dice you could choose what would be the next bar in the music. So this minuet is composed by somebody by using a dice and using the table. Actually, you can play the game today. This is an app for the musikalisches Würfelspiel of Mozart. So you can use the app and compose your own minuet, and it sounds like Mozart could have made it. Right? So very exciting. And then I found, so this is the first book pretty much on computing that I bought. It's experimental music composed with the help of a computer by Hiller. And Hiller calls this one the Iliac suite, the Iliac suite for string quartet. So what Hiller was doing, he was making a decision, was considering decisions in composing, like how many parts would be in the score, and then for the first part, would it be slow or what that would be the speed, using some kind of random devices. I read the book and I was excited. A big chapter in the book was just on how to program a random number generator. Nobody had decided how to make a random number generator before. Hiller did, and he used that one. And the score here is the first part of a string quartet, and it would sound like this. Okay, so exciting times for me, and this is Hiller at his machine. Okay, so based on all of these things, apart from the task that my boss sent me, like teaching programming, like using the computer to build and to check and to compare mathematical models of human reasoning, of human decision making, I thought, can I do something about music? So I was building Markov models of sequences of notes. So here we have two composers of the early 16th century, Di Lasso and Josquin des Prez, two, let me say, Dutch composers. We consider them in the Netherlands, right? And these two Dutch composers composed melodies, and each of them has their own kind of characteristic sequences of notes. Can we model that? Can we use the model to compare the composers? Could we use the model if we have a new piece of music that is supposed to be of the early 16th century and find out who could have written that one? So I was going to build Markov models where if you have a sequence of notes, what is the probability for the next note, and compare them between the composers. Until my boss found out. And the professor of cognitive psychology said, this is not psychology, stop it. Too bad. So, in 1966, I wrote my master's thesis. Even next to my job, I had to finish my psychology study. And the master's thesis was on mathematical models, mathematical learning models, as tools for computer-supported learning. There was one computer in Amsterdam, right? But the idea was, suppose that this computer could be used by a school kid, and that the school kid would have to do a lot of exercises, let me say mathematic exercises. Now, my computer tool would find out after a couple of exercises how much the school kid was learning, and the computer could choose the next exercise that fit the level of learning of the school kid. And in order to do that, I needed to build mathematical learning models, and I needed Bayesian statistics to compare the probability of one of the learning curves to be the correct description. And the computer science, and the cognitive psychology professor had no clue. And he said, I don't understand. And I said, ask a mathematician. Be aware, computer science didn't exist. We didn't even have a word for that in the Netherlands. There was no computer science. So my cognitive psychology professor asked the mathematician, and the mathematician said, all the numbers and all the models and the formulas are correct. So I got my master's. And then in the next year, together with a colleague, we actually published a book at Academic Press Rotterdam, and this is a handbook of how to program a machine in ALGOL 60. And immediately that book was on the desks of the mathematician students, because they also needed to learn how to handle computers, right? And then in 1970, IFIP, who is the father of Interact, right, in a way. IFIP had the first world conference on computers and education, and I got my first invited talk there. So this is the IFIP World Conference, and this is the list of invited papers, and there are a couple of hundreds of submitted papers. I didn't submit, so I was invited, and I was in the same session as people like Simon Papert and Gordon Fast. And I was scared to death as a young guy, and these were people who really were world known, right? But so I gave you a list of papers, invited papers that really focused already on, let me say, human-computer interaction. We didn't use the word, but these are papers on, like Gordon Pask, fundamental aspects of educational technology. So Sylvia Sharp, computer technology in education. Simon Papert, teaching children thinking. He was doing a very exciting talk about how to challenge people, young people, to do computation by playing in a way, right? And their playing was understanding computation. So these are some of the really early papers that we now would recognize as human-computer interaction. And this is my paper, which is, you see, lots of formulas, lots of graphs, boring, but I was proud. And we found out at that time that ALGOL 60 was definitely the preferred language, at least in Europe. I was, end of the 60s, I was at a conference in the UK, and there was a young guy, Thomas Green, and Thomas Green told us we are from different countries, but our main language is ALGOL 60. Can you imagine that one? That was the language that people used when they would communicate with a computer. Interacting with a computer meant being fluent in speaking and reading ALGOL 60. Well, the 70s. We got new machines, we got more machines. Actually, we called it mini computers. They were as large as a dressing cabinet, right? Like this size. And they had no longer paper tape, but they had magnetic tapes. Luckily, we still had the flip-flops and the rows of lamps, right? So mini computers, and DEC, Digital Equipment Corporation, was at that time in Reading, UK. I went to Reading to study their machines and their operating systems. And my psychology lab got its own mini computer. We call them mini because the X1 computer that I showed you actually took a complete classroom. Right? Oh, I forgot to tell, the X1 computer, we had 8K of memory. This is not 8K bits, but 8K words. And the word was 27 bits, and in fact it was 32, but they used 5 bits to check the parity and to make sure there were not too many bugs, because bugs were really alive at that time, right? So, and this machine had much bigger memory and much easier, or no, not much easier, but much more powerful storage for your data and for your programs, magnetic tapes. And I kept my own magnetic tapes in the cupboard, right? These are my tapes, this is my data, no cloud, just in the shelf or in the drawer on my desk. And this is the Freedom Flexor Writer. The Freedom Flexor Writer was the terminal globally used as far as I could see. I still think, at least in Europe, this was the terminology used. It's still wood-handled paper tapes. The good news was the Freedom Flexo writer was connectable to the machine by a telephone line. You can see that, so this is an acoustic connection. You could, still the old telephone, you can see here, right? And when you dial the number, you listen, you got some kind of beeps, and you know now I should put, and actually in the office in Amsterdam, we managed to have 10 schools, and each school had a Freedom Flexo writer there, and the school could use the telephone, and in some of the classes, all of the kids could use the machine for 10 minutes or 15 minutes every week. And we could experiment in supporting learning with the computer. And now it was real, right? The schools really had connections, and it worked to a certain extent. And now we use the new language, Unix. And Unix was labeled a convenient platform for programmers. Unix allowed us, it's an operating system that allows you to program, at the same time, there was a book, a psychology book, Human Information Processing. Psychology was really getting mature. Look at the authors. There's somebody called Lindsay and somebody called Norman. Norman was a psychologist. You will find him later on as a computer scientist and a user interface designer, but at that time he was a real psychologist working on theories of human behavior, how people think, how people decide, how people learn, how people compare, and so on. And this was the handbook. So in my department, when we were teaching cognitive psychology now, this was the book, right? Nothing about computers, by the way, but very relevant. And then research started to spread out, and we started to find out what people were doing. So in my university, VUA is Free University of Amsterdam, as we pronounce it. In Amsterdam, we were developing the people's, no, it's not, this is an error, it's the pupils' programming language. It was a programming language for kids, right? And Thomas Green in Sheffield at that time, he wrote a system called the Hungry Hare. Was again a programming language for kids. This was about the hare, and the hare was, if the hare wanted to eat, you could eat things that were leafy or things that were sweet, and so you could program the menu of the hare by choosing. And the people's programming language was the pupils' programming language. And Gordon Pask collaborated with us on looking at individual difference, because some people are like imagers, and they want to see structures on a screen. And some people were verbalizers, they wanted symbolic interaction. So with Gordon Pask we could collaborate and develop an approach to differentiate between computer users. Most of the time, by the way, focused on kids, because the adults should use Unix and Algo, right? And for adults, we said, you shouldn't complain, shut up. This is the language, and if you are clever enough, you will be able to handle it. But kids need a nice language to talk about the hare that needs to be fed with leafy stuff and with carrots and so on. My wife, this is a private example. Ellie Lammers is my wife since a long time, and she was at the Free University, like me, no education whatsoever apart from primary education. She was employed to be an administrative support to the group, the computer group in the psychology lab. And in order to do that, she had to learn Unix, and she actually designed a calendar system for team projects. We did lots of European team projects, and she designed a database for scientific literature. None of this existed, so if you wanted to do it, learn Unix and build it yourself, right? And even then, there was not a course for us. Only in the 70s, there came a guy in the mathematical department who was the computer science professor now, and we immediately collaborated, obviously. So, and if we wanted to publish our stuff, these were the journals. So the proceedings of the DECUS Eurosupport. DECUS was the Digital Equipment Corporation Computer Users Group. And this is where we published our stuff, or the Digital Equipment User Society, the international, so the one was European, the other one included digital equipment users outside of Europe in a way, right? So very much focused on a certain type of computer architecture and very much focused on people who used that system and published their results. Because the psychologists got worried. Is this really psychology if you are talking about computers and mathematical models and interaction stuff and languages, funny languages? And by the way, we were not aware of that, but in 1976, the first Apple was built. I didn't see that. Nobody did see that in Europe, but it happened when we were publishing, using the Dick's PDP-11 machines and so on, and publishing or we published also in the Unix group, Unix user group bulletin. These were the ways where we could do our stuff, and two funny guys in the garage built this one. Right? Okay, and then the 80s came and we were working more and more internationally, and we were also considering the fact that computers could be even smaller than mini computers and maybe more shareable for people. Be aware, this was the network in Europe. My email address, if somebody wanted to send me an email in Europe in 1987, he had to know the different machines that would reroute my messages. So this was the way to reach you. And at the end it says MC-fax. We called MC-fax. MC-fax is the fax machine at the mathematical center in Amsterdam, and we called MC-fax the gateway to Europe. So anybody in the States who wanted to talk to us, we could say, go to MC-fax and then use Botter. Botter is the machine in my lab, and then use my username, right? And so anybody outside of Europe could find me, because they should know the path to MC-fax. This was email. And actually, not only email, I was working at that time with a colleague, Michael Tauber. He was in Austria, and at the University of Linz, we shared a login at the Unix system. We call it Miger, Michael Gerrit, Miger, and we could both log into Miger. I can now actually say that our password was an Austrian name, Brunner Feldliner, which is a good Austrian wine. You could try it. And so this was the password. We both could log in, and we could find out whether the other was also there. And this is how we communicated, by typing in the file, right? So this was kind of using the internet. We didn't use that. We knew the path to each other's machines, and we just log in a shared account in the Unix system. And actually, Unix systems allow you to structure. So the Unix system of Ellie and me were combined. So we could enter each other's, but the other people of the department had to, we didn't leave them to show everything. And when I was working at two universities, I could link the Unix systems of the two universities as one big hierarchical tree and move from one to the other. They don't allow us to do that anymore, right? Because this was a challenge for the system. But Unix allowed, and the machines allowed. And this is the map of Europe, and this is the machine. So you know where to go. And then there was an email. An email by a guy called Norman. And Norman was now no longer a psychologist, and he wrote an email about the trouble with Unix, and it stirred the world, because everybody was using Unix, but Donald Norman said, Unix is not a nice language for people. Even if you can do very powerful things, it's also a disaster in a way. And you couldn't require everybody who wants to use a computer to just be a Unix expert and do his thing. And his email went across the world. I remember people reacting on that, and we forwarded it, and we reacted, and later on it got printed. Well, for me this was an eye-opener. People were criticizing the only language we could use, right? And so consequently we started thinking about, could there be something better than that one? Well, the mini computers in the 70s were still running uses. But in the 80s we got personal computers. Personal computers are smaller than mini, and they are personal, which means you could own one, and you wanted to own one. And we had a choice. So Ellie and I had some money from a project, and we could buy our own computer, and we could choose between direct manipulation on a desktop or a disk operating system, which looked a lot like Unix. So this is the Xerox Star in 81, and this is just an example of the screen. The important thing was you could point, so you use the mouse, much more advanced than Doug Engelbart's one already, and you use the WYSIWYG. What you see is what you get. So you, in a way you could say, here are my programs, and there is my data on the screen, and you move them around by pointing and by dragging, right? And you could drag your data on a tool. And nowadays we would call them apps, but we certainly didn't call them apps by that time. So if you use the machine, you should be sure you have the right programs and you have your data, and then you move around. And if you see that the data go to a program, you understand the data go to a program, right? So this is the example. And this is the Macintosh. And the Macintosh looked a lot like Xerox Star. And in a way, the Macintosh became much more popular because Xerox focused on printing machines, thought there's more money to get printing machines. Companies do stupid things, by the way, sometimes. I showed you the X1 computer, the 8K computer that I was using in 61. That computer was built by people that worked at Philips. Philips, the big Dutch electronics company. And Philips decided they should stop doing that because Philips wanted to focus on light bulbs. And so they gave them a little bit of money and said, set up your own company. And they set up their own company and built 28, right? Philips was not interested. Light bulbs is a better, there's more market for light bulbs than for these computers. And Xerox, and so the Xerox Star and the Macintosh won because Xerox didn't show interest. Copying machines had a better market, apparently. And this is the screen. It looks a lot like the safe. You have stuff, you have programs, and you could move things with your mouse. So direct manipulation, drag and drop, and this is how it worked. And the Dutch government gave us, there was a big task. We had it at that time in the Netherlands. Well, who knew about computers? Well, some mathematicians, some psychologists, some people in the medical sector, but not too many. And the Dutch government thought maybe everybody should know. So the kids at school should learn. So the teachers at school should learn. So we had to train the teacher trainers. There's teacher trainer colleges in our country where somebody who wants to be a teacher will be educated, and we educated the educators. And this is why we could buy a machine. And we choose another one. We choose this one, which is a DOS machine, disk operating system. Disk operating language looked a lot like Unix, but now you could put your programs in and you could put your data in. And this is how the input looked like. It was a disk. We call it a floppy disk. I think floppy disks are now extinct, right? They are in the museum. But actually, so this is the screen, the cheap version, right? We couldn't afford the more expensive one. I think the thing costed like 4,000 euros at that time, but this was like 8 months of salary. So we were so happy with the grant of the government. And we carried it around. We went to conferences with our personal computer. And it just fit the overhead compartment in the plane. And the keyboard locks up to the screen. And it's heavy. So we had 2 wheels, little carriage with 2 wheels to run through the airport. And we took it to conferences and meetings. And it ran a disk operating system. So Nowadays, I still see this icon, right? You remember where it came from. Now you know. Okay. In Europe, we started to collaborate. Actually, the European Union was very advanced in considering that universities and industries should collaborate on new technologies. So first we had cost projects and then ESPRI projects. The cost projects were first, and the cost projects were still projects where mainly the academics were collaborating. So we were in many cost projects, and all people in Europe who were working on something related to human-computer interaction or user interface design try to be members of cost projects, which allowed you to meet. So we had for 5 years, we had meetings every month somewhere in Europe, and we could publish together, and it really helped. If I look at my publication list, I can see for the 5 years that we were in cost project, I can see every year we had like 8 publications with people from the UK, from Sweden, from Romania, from Germany, from France, from Italy, and we all worked together, and we taught each other, and we learned from each other, right? So we got our education, in fact, by working together, and so mainly computer science, psychology, and cognitive ergonomics. Cognitive ergonomics, at that time, a new kind of word, developed mainly in the UK. Brian Shackle, by the way, was definitely responsible for setting up that idea. And the ESPRI project that came next were more strict. You should collaborate with industry. And if 5 universities and 2 industries work together, the industries actually should show that they put money in it, right? So that was enforced collaboration, which helped a lot. And so we were lucky to have networks of excellence. And then the industry started. So IBM started to build science centers. We had one in Germany, IBM Science Center Heidelberg. And they hired people like me for a couple of days a month. So 1.5 a week a month, we went there and we met other people, and we suggested and supported and criticized user research. IBM did user studies, and we had a one-way screen, so we could sit and see the person working with funny systems that still were not really well designed. I've seen users crying behind their machines, right? Because they always think the computer is clever, I'm stupid. And it really happened. So, but anyhow, IBM was keen on doing that, and they did research. And the good news is that they allowed us to publish. IBM didn't want to keep things secret. A lot of things have been developed and evaluated at IBM research centers that were never actually used by IBM, but used by other industries. But they really produced stuff. And then, I can proudly say, in 1982, Thomas Green and Ellie Lammers, my wife, and myself, we started the European Association of Cognitive Ergonomics and had the first conference in Amsterdam. Obviously, Thomas Green and my group, we were collaborating on languages for simple people, let me say for kids, but we found out in France, in Romania, in Italy, in Scandinavia, there are other people. So we had a conference, ECE, European Conference on Cognitive Ergonomics, and we just dare to say the first European conference, meaning that there should be a next one, and we founded the association, and last week was I think the 30th conference. We skipped some years, and then we collaborated with CSAPC, Cognitive Science Approaches to Process Control, which was originally mainly the French and the Italian people, and we joined forces, and now we have every year still this conference. So just last week we had a conference, and some of the people in this room were there last week, right? Okay, and now I'm going to show you a little bit what happened in Europe, because at that time it became clear that in different parts of, I would say the world, but let me say honestly, in Europe, in different parts of Europe, there were different tastes, different focus, sometimes different theory or even philosophies behind working on human-computer interaction. So Scandinavia, they did a lot of work, and Erik Holnagel actually founded at that time, it's about 82, founded the journal cognition, technology, and work. I think it tells the whole thing. And they focused on ergonomic but also safety issues, because they were looking at people collaborating with cars, people collaborating with planes, people collaborating with traffic in general, and people collaborating with process control situations, right? So safety is as important as usability, or both require each other, you could say. And also in Scandinavia there was Jens Rasmussen who developed a theory of human decision making, saying that if you don't know, you have to think and make up your mind. If you already have done it before, you can apply rules, and if you have done it many times, it's an automatism, it's a skill, right? And the theory with Jens Rasmussen tells us how to teach people, or how to let people learn to develop skills, and how to identify at a certain moment at which level people are. So what they need to make up their mind and to hit the button or make a decision or turn the steering wheel. And then we had a big thing called, what we call the Scandinavian approach, which was, interestingly, was in a way triggered not by the scientists, but by the trade unions. The trade unions were saying, if people are going to use these complex machines in their work, in their offices, in their industry, then the people are going to do the work should be involved in the design. So they required user participation in design teams. They don't say it's a good suggestion to talk to people. No, they should be a member of the design team, have a say in decisions. And so these are some names of people who work on that. And they developed the approach participatory design. So this is design where in all phases of design, the potential users will be actually participating, sitting around the table, making the decisions, right? And obviously this was more focused on collaboration, on people in the company, on the group of people doing the work, than on individual people. And a very important approach that lead later on to conferences like CSCW, Computer Supported Collaborative Work, right? So the Scandinavian approach from the start focused on the people who actually have to use your systems, and on the context in which the systems are used in a team, in a social setting. And then there was another thing that started, at least in Scandinavia, was the use of activity theory. Activity theory, in a way, was both based on Leontiev and Soviet Union psychology, philosophy, I should say. And activity theory was then developed and then taken over, for instance, Boninardi early on. She is in the US, in Cupertino, close to Apple. They took it up and collaborated. Viktor Katilinin, a guy formerly from Russia, now in Sweden. Some of us met him last week at the other conference. They worked together, they wrote books, they made this activity theory approach clear to people who never heard about that. And I should find my time. Germany. In Germany there were workshops, and the first workshop was arranged by Günter Pfaff, and this was on user interface management systems. It was at that time a bright idea to have a way to design your system independent of the platform, whether it's for a PDP-11 or for a desktop machine. And so they developed the Seeheim model, so the typical European way of designing a global model for the user interface that could be tailor-made for different platforms or for different applications. And then there was workshops, and the good news is that in Europe many people speak many languages, so we could attend the workshops even if we didn't speak or are fluent in German. When I went there, I was allowed to speak in English to the Germans, right? And we could communicate. So this was the informatics and psychology workshop. They got Psychologie des Programmierens, you can understand, the psychology of programming and so on. You can see how the field changed over the century, over the years, right? And then there was the German Gesellschaft für Informatik, and they later on considered themselves the software ergonomy, I think, yeah, software ergonomy. So And then there was this McIntyre framework. Be aware, at that time Europe was split in, let me say, the Soviet Union and related states and the west part of Europe. And in a way, politically speaking, we are supposed not to talk to each other. And in fact, we collaborated strongly. So mainly the psychologist, Friedhard Klicks, he was a professor in East Berlin, as we call it that time, and he arranged with his colleagues, Hartmut Wanke, but also with people like Norbert Streitz, regular meetings where people from all over Europe, from the UK, from the western part, and from the eastern part, the Soviet Union part, met and worked together and published. And this is where we invented the idea of taking care of the mental model. Norbert Streitz was instrumental in that. And in the UK, we had several institutes like USAT in Loughborough. This is where Brian Shackle, in a way, created the vision on ergonomics applied to computers. So we call it cognitive ergonomics, right? And you are all aware, Brian Shackle is the father of Interact, right? He's the founder of the first one, and so on. And then we had this funny thing. Medical Research Council Applied Psychology Unit. What's that to do with computers? Well, this was the home for many research in the UK in the 80s to do research, so like Simon Green and Guest, Neville Murray, and they collaborated. So we could go there, they would come to us. And then they collaborated in this Esprit project. In France, Indria, big research institute, was founded, and then there were people like Sebillot and Scapin, and they developed task analysis. I still remember, they wrote in French, and for people like me and for people from the UK and from Scandinavia, French is not easy to read, really not. And then Suzanne Sebillot and Dominique Scapin published their first paper on task analysis. And I remember calling my friends and telling them, here, now we can read their stuff in English. And now we understand what task analysis means, right? And the French taught us this, and we were so happy. And the French group and the British, they worked together a lot. And in the Netherlands, we had the Dutch Computer Society and the Dutch Ergonomic Society, and they joined forces and said, let there be a working group on human-computer interaction. And Ellie and my wife could set up this thing. I will speed up. And we collaborated. And in Spain, several people from completely different backgrounds. Cognitive psychology, cultural heritage, psychology for people with, informatics for people with special needs. They collaborated and founded IFO. Originally the Spanish organization, later on including Portugal, and taking care for Latin American, communicating with Latin American developments. And in Italy, they worked in the same European projects, and people like Sebastiano Bagnara. He was originally a philosopher. He worked on cognitive psychology and human-computer interaction, and they collaborated heavily with industry. The Italians always worked with industry. And in North America, at the same time, and now we found out, there were people like Carpenter and Newell, they developed models like GOMS. You might still know GOMS, and the keystroke level model, KLM, and we had Fitch law. And interestingly, this is what in Europe at that time we called the American approach. Jack Carroll said, the theory is in the artifact. Why is the mouse relevant? Look at what you can do with the mouse and you find out why it's a good idea. In Europe, we had Gunther Pfaff saying we should build a general model for user interfaces. And if it's for moving, we might model a mouse. And Jack Carroll said, look at the mouse and find out why it's good. At that time, it was kind of different. And then the same year, we founded the ECHE conference in North America. ACM founded the CHI conference series. And then Interact was founded in in 84 by Brian Shackle, and it became first every 3 years and then every 2 years. And in a way, originally Interact wandered around in Europe, and then it went beyond and became In fact, the first international conference that went beyond their part of the world, right? With a strong local flavor. Everybody who was here last night have seen the strong local flavor of Interact, right? We would never have had such a night in any other location, that's clear. Personal, yeah. Around 1980, the computer science department that was just founded asked me to come there and teach. So I was leased by the psychologist, right? And then the psychologist in 85 told me, you and your group are not contributing to psychological theory, you are just using it. So we moved. But by the way, the same happened in the UK. So people like the Peter and Hilary Johnson, they moved from psychology to computer science. So Ellie and I moved in 1990 to computer science part-time and to the Department of Cognitive Ergonomics in Twente. And so, going global, well, InterChi, we already heard from your introduction, InterChi was the largest Interact and at the same time the first Chi conference that joined. And it was in The Hague, and we had 1,600 people, and the Chi conference continued to be regularly outside of Europe, and now even outside of North America, in Europe, and now even to Asia. We have been there in Seoul, Korea, and we will back in 21, and I'm not allowed to tell you where. We joined forces, researchers, teachers, and practitioners, and we meet. We can have a sabbatical somewhere else. I can invite a teacher from another country if needed. I'm invited to teach somewhere else. Researchers work in projects internationally. And we don't know where we are anymore. But our domains are no longer go to this machine, go to that machine, go to MC-Fax, go to Botter, go to... No, we just are in an institute Gmail or an institute, or we have .eu or whatever, right? So we don't know where things are, apart from when you are in China. I happen to teach in China most of the time, and there I have to put my videos on Youku, right? And WeChat is there instead of Facebook. So, I've been teaching personally in many locations in Europe, and originally these were my courses: Introduction to HCI, User Interface Design, Visual Design, Basic Research Methods, and Human Information Processing. Why Human Information Processing? Well, in many locations, if you are in the computer science faculty and you teach cognitive psychology, people will kill you. So you teach Human Information Processing. And that's fine, it's information processing. Good. So, currently, Ellie and I are still traveling the world to teach, but in interesting locations. We have been teaching in Sardinia up to recently. I'm still officially there, in the Faculty of Architecture and Design. These are people who design smart buildings and a smart marketplace, right? This is not computer science at all. But in Spain, Faculty of Computer Science, where most of the students, by the way, in my class are people from museums, museum curators. They take my classes. In Dalian, it's the SINA European Usability Center, and in Lianon, it's the Luxun Academy of Fine Arts. So we teach in OOPS. And the new courses are Service Design and Design for Cultural Heritage. And this is how the new curriculum for ACM looks like. We are no longer speaking of human-computer interaction, we're speaking of user interface design. And so ACM, SIGCHI decides that, well, maybe we should look at a different approach. And maybe I stop.
You started your telling your experience about as a musician and how music could at that time be programmed, and then your professor said no, this is not psychology, so forget it. And now you can see a lot of musicians playing with these digital machines and making mashups, new tunes. How do you perceive the evolution of that, and how you consider your career? Was your professor wrong, or he was right and said, no, go for classical music and not?
Well, in a way, the psychology professors, their mission was to develop cognitive psychology. And you should be aware, when I was at university, in psychology, we still had the course in Rorschach test design, right? And Rorschach test interpretation. So psychology was very fuzzy kind of thing. So they were so keen to have a decent theory of human memory, including reaction time measurement and so on. So in that respect, we stepped beyond cognitive psychology. On the other hand, nowadays, we can teach in many different environments and we can contribute. My students in the Faculty of Architecture or my students of Lucian Academy of Fine Arts, they have no problem building anything whatsoever in computers, in computing. But they use it for their goal, for developing an art installation or for building an interactive marketplace and so on. So disciplines are good for teaching, but not for practice. Can I say that? I think so. And I'm still using one of the next slides is showing that now my Italian student built a website for a collection of musical instruments and have a professional player put his music on the website, right? So, I mean, we can still do music, and actually music now appreciates, like fine arts appreciates our approach. I didn't ask to be appointed. They said, please come and be a professor.
You gave us examples about the telephone and the floppy icons. So, do you think minimalism is killing the, form of physical products, and do you think that has an impact on the coming generations?
Yeah, in a way, when we are trying to visually represent concepts, most of the time we go back in history and say, how did it look like yesterday? And we put it there. But things develop very quickly. Remember, maybe you still remember the first time you bought a smartphone. Before that time, the concept didn't exist, right? And now children are born with a smartphone in their hands. So so we should be very careful about icons. Before long, icons get to be completely abstract symbols, right? And which is fine if people love abstract symbols, or we should change it. Or we could even consider allow people to take their own icons or symbols, right? Create them, why not? Because sometimes they look funny. For me, it looks funny because I've gone through all the stages of the telephone, the telephone with the buttons, the telephone in my pocket, the smartphone, and so this doesn't look in any way like the thing, right, anymore. So we should be, traditions are fine, but it should be usable. So make sure new people understand. And if they say it's a symbol and the symbol is clear for me, okay, who cares?
Good morning, Kaveh Bazargan, National University of Iran. Thank you very much for your inspiring talk. You've been pioneering HCI since your childhood, I think, and still now. I'm really thankful also to the ACM and you, because you've provided some countries which are Asian countries. 2 days ago, there was this symposium on HCI research in Asia. So I wanted to know, what is your specific recommendation, given the background you showed us, because it's really nice to see how people shared devices. Now there is still in Africa villages, there is one TV for whole the village. They put it in a cupboard, they open it, people sit and they look. People are becoming selfish, specifically in Asia, even in Iran. Everybody owns something. My recommendation that I'm asking you, because we've had this symposium on HCI research in Asia, in many of these countries there is no SIGCHI chapter and there are no conferences on HCI. And for me, it has been a pleasure to come here because it's easy to get a visa to come to India. What would be your single recommendation for, I think there are, 65 countries in Asia. Of course, most of them are really advanced, but some of them, they have no clue of what HCI. What would be your single recommendation so that in Asia, HCI research would have a say? Thank you.
Yeah, well, I couldn't give a single recommendation because exactly like you say, the difference is so large, right? So big. But a couple of things. Be aware, in some countries, I know China a little bit because I work there. In China, there's now, Danzu should correct me, I think 800 million smartphones. Yeah, she doesn't. 800 million smartphones in China. And I'm pretty sure that maybe 100 millions of the users actually cannot even read. But they use their smartphones well, they can read the icons in a way, right? So for them, it's the way to survive. It's the way to pay, it's the way to order things. In a way, the smartphone is anything you need to get your food, to pay your bills, to negotiate with the cab driver and so on. On the other hand, whenever we have a possibility, we should focus now on context, on the social aspects. One of the slides I couldn't show you is where people are walking together. There's a poster with QR codes. And one explains and the other takes the phone and they are collaborating, in fact, through the internet, because the QR code points somebody to an interactive website, but they are discussing together, right? So allow people to discuss together and say, this is my stuff, this is your stuff, let's compare. And technology now is well prepared to do that. I mean, just a QR code at the moment, and we get much better things very soon, and the clumsy smartphone, which will be replaced by much more easy things like a jewel or a watch or whatever. But it allows us to say, look at my stuff and let me discuss your stuff. Right? In negotiation, if I want to buy something you're selling, or if you know something I would like to learn.
Thanks for really a great talk. Truly enjoyed. So in past 50 years or so career, when people ask you what you do, how you introduce yourself, did it involve different version in past 50 years? Thank you.
Well, my personal secret is coffee, right? Espresso.
Okay, thank you very much, Gerrit.
That's it.